Hi everyone. So for the unit 3, we'll start with 3.1, the periodic table. So the periodic table is arranged into 4 blocks associated to the 4 sub-energy levels. So here you have the S block. Here you have the P block. So P block here. This is the D block, and the last one here, this is the F block. Why do we call them SPD F block? It's because of the electrons that are being filled in the shell. So if you look at elements in the S block, the last electron is filled in the S subshell. Here it's filled in the S subshell again. So this is called the S block because the last electron is filled in the S subshell. If you look at the P block here, the P block, if I take any element, when I'm writing the electronic configuration, the last electron is filled in the P subshell. So that's why it's called the P block. Same for the D block. The last electron, if I take for vanadium, the electronic configuration, the last electron is filled in the D subshell. So this is why it's called the D block. And the F block, you have the lanthanides and the actinides. So these elements here, right here, so these are the lanthanides or lanthanoids, and here you have the actinides or actinoids. Okay, so these are parts of lanthanides from here, so actinoids from here, and lanthanoids from here. Okay, so the periodic table is arranged in increasing atomic number. This you already know. You already know that elements with similar properties are found in the same group. So you have all the different groups here. So the different groups are listed over here. And the first group, this is called the alkali metals. The second group here, this is called the alkaline earth metals, and you have this one here, the one highlighted in orange here. So these are the transition elements, and you have in green here Group 17, these are the halogens. And in purple over here, you have the noble gases. So these are naming of the different groups that you should know. And the period number is the outer energy level that is occupied by electrons. So if it is in period 1, which means that it's the first outer energy level, period 2, second energy level, period 3, third energy level is the outermost. Let's see how it works. We're going to see that in more details. And the number of principal energy levels and the number of valence electrons can be deduced from the position in the periodic table. Let's see this. So let's take rubidium, for example. Rubidium, let's say we have to write the electronic configuration. If you look at it, it's found in the 5th period, which means that the last energy level has to be the 5th energy level. And we will write the electronic configuration by looking at the noble gas that is just before it. So this is krypton. So we'll start the electronic configuration from krypton. So that's why we'll write Kr. And because it's in period 5, so 5, and because it is in the S block, so S, and because it is in group 1, so 5S1. So here you have for rubidium. If we do for astatine, so let's look at astatine. Astatine is here, and we'll do the same thing, nearest, like the noble gas which is just before it, so that's argon. We're not going to look at krypton because krypton is after astatine. We'll look at Sorry, that's arsenic. Yeah, so for arsenic, we'll look at argon, which is the noble gas before it. So argon. And because it is in the fourth period, so the fourth energy level, the last energy level filled in is going to be the fourth energy level. And because it is in the P block, so you'll be filling S and P. So we'll have 4S and 4P. And because it is in group 15, so what we used to know as group 5, so we'll have 2 and 3. So that makes a total of 5. So this is group 5, right? And we can try another one. Strychnine. Barium is here. So it is in group 2 and it is in period 6. And the noble gas just before it is xenon. So I'm going to start by writing xenon. And I'm going to write, because it is in period 6, so I will write 6s2 because it is in group 2, right? So this is how you use a periodic table to write electronic configurations.